Hello everybody, welcome to Welch's Math Class. We are back once again to talk a little bit more about solving equations. And so today we are in section 9.7 of your course compass material, and we're going to be talking about solving more complex equations. What I want to do today, guys, we have talked up to this point about some of the skills or tools that we need to solve equations. We've talked about simplifying expressions, we've talked about transposing, we've talked about using the multiplication principle. What I want to do today is give you a strategy that you can pull all of those things together into this strategy where you can solve just really any equation that we'll have to deal with here in Math 032. So let's take a look at that. First of all, I want you to be really clear that your goal, your goal in solving an equation, is to isolate the variable. Okay? Our goal in solving any equation is to isolate the variable, isolate the letter, get it essentially on one side of the equal and get the answer on the other side of the equal, and then we have an answer. So that looks like, in the end, looks like either x equals, and you have an answer over here, or you could flip sides and you could have an answer on the left side equal x. And so in the end, what we're trying to do is get that x by itself on one side of the equal. It could be on the left side of the equal, or it could be on the right side of the equal, and what you have on the other side of the equal, assuming it's simplified all the way down, is your answer or your solution to the equation. So we're gonna manipulate equations. We're gonna do a lot of things to equations, but bear in mind, in the end, what we're trying to do, everything that we do to the equation, is to try to get it to the point where the x is isolated, it's by itself, and the answer is on the other side. So let's review some of those tools that we've got and show you a strategy, a plan to help reach that goal. And so I call this Welch's plan to solve equations. Okay? And then this is particular for the equations that we're working on here in this section, what would be generally called linear equations of one variable. You'll get into more detail on that in Math 101 and 102. But for the equations we're dealing with, this plan is going to work extremely well. In fact, I'm going to be willing to guarantee you that if you know how to execute the steps in this plan, and you do them in the order that I give them to you, you will get every single question as far as solving equations correct. This is a foolproof plan. Yes. All right. So let's take a look at it. The first step, what I always want to do is check to see if I can simplify either side of the equal. So first I want to check, is there anything on the left side of the equal that can be simplified? Is there anything on the right side of the equal that can be simplified? Remember the two ways we simplified expressions. The first way was we essentially looked to see if we could distribute anything. If there's parentheses, is there something outside those parentheses that could be distributed? The second way that we simplified was to combine like terms. So if we took the equation, for example, and maybe we can be working with an equation as we go through this to kind of give an example of what we're talking about. If I took the equation 3 times 2x minus 4 equals 7x minus 8, let's say, plus 3x minus 4. If we took this equation, for example, what we'd want to do is we'd see the equal, we'd see the expression on the left side, we'd see the expression on the right side. So the first thing I want to do is check, can I simplify on either side? And now I've created an equation here where we can actually simplify on both sides. So that's what I'll check for first. So when I simplify on this left side, I'll get 6x minus 12. And when I simplify on this right side, I'll take the 7x and the 3x and put those together as like terms, and I'll get 10x, and the negative 8 and the negative 4 give me a negative 12. Give me a negative 12. Okay, so first I'm going to check to see if I can simplify on either side of the equation, and I'll do whatever simplifying I can do. Not every equation that you run into will need to be simplified on either side. Sometimes they're already simplified on the left and right, but we at least want to check before we do anything else. We don't want to start with other things until we simplified both sides as much as possible. All right? Second, after this, the second step is to transpose. Transpose. You remember transposing? It's where we move terms from one side of the equal to the other, either which way, and we can do that as long as we change their signs. So we want to transpose to get like terms together. Okay, so in the equation that we have here, 6x minus 12 equals 10x minus 12. Okay, in this equation right here, we like for the 6x and the 10x to be together. We like for the negative 12 and the negative 12 to be together on the same side of the equal. So what I'm going to do is I'm going to simply take, I suppose I'll take the 10x over to the left, and so I'll go with a 6x over here on the left and a negative 10x. And I'll take the negative 12, this negative 12 over here to the right, and so what I'll get is a positive 12 when I move it over, and this right here stays a negative 12. Okay? And so we've transposed. Now we simplified that a little bit more. I'll get a negative 4x equals 0. Negative 4x equals 0. So my second step was to transpose to get like terms together on the same side of the equation. My last step, okay, step 3. I don't know if I got room to put it down here. We're going let's just call it last. Use the, and we said multiplication, multiplication. And you can review that work, that session we did on the multiplication principle. We use the multiplication principle. Okay, remember we use that multiplication principle to get the variable isolated, to get the coefficient off the variable. So in this particular problem, just go ahead and copy that. If you need to pause the video here, pause the video. I'll try to get out your way for a second. You can pause the video and do that, but we're sitting here with our equation at this point is negative 4x equals 0. Remember, we're trying to isolate x. Okay? If you need to pause and do that, do it. Let me, so I'm to the point of negative 4x equals 0. Alright, so the last step then, if I'm sitting there with negative 4x equals 0, is to say, okay, what I'm going to do is get that negative 4 off. So I'll divide by negative 4 over here and divide by negative 4 over here. This is the multiplication principle. And those cancel, and it leaves me x equals 0. So my answer for that equation was 0. So we used a 3-step strategy plan in order to solve that equation. And I want to tell you that those 3 steps are what you need to solve any equation that we're gonna deal with here. So let's do a few and kind of get a sense of what we're looking at here. First one I want to do, the ones I'm going to do here with you are going to be equations that are going to be very similar to what you're going to see in your homework problem. So hopefully this will be helpful to you. We'll have 14 equals 4x minus 10. Okay, so now just remembering that our 3-step plan was first simplify. I'm going to do it very abbreviated here. Second transpose third or last, use multiplication principle. Okay, these are my 3 steps. So when I look at the equation that I have right here, and I look to see if I could simplify on either side, well, here's my equal. Okay, on the left side I have a 14 and I can't simplify 14. 14, oh, lost our light. Let's get our light back on. All right, so 14 is just 14. Over on the right side, 4x minus 10, those are not like terms. We can't simplify that. So really, we checked step 1, but there was no simplifying to do. So we're going to go to step 2, we're going to transpose. Now what I notice here is I have some like terms that are not together. The negative 10 is a like term with the 14. I'd like to get those together. So I will transpose. I'll leave the 4x alone. I'll leave the 14 alone. I'll transpose the negative 10 over here, and it'll be a positive 10. Positive 10. Now I'm going to go ahead and work that out, and I have 4x over here, and I have 24 over here. Now remember, it doesn't matter if the x is on the left or the right. It's good either way. And, and so at this point right here, I've done my transposing. Now I need to clear this coefficient, so remember we're going to use the multiplication principle in our last step. We'll divide by 4 here, divide by 4 here, cancel, and x equals 6, and so 6 is the solution to this equation. All right? Copy that down, pause the video if you need to. We're going to run on to the next one. I want to jump through as many of these as quickly as we can to give you some good looks at some different equations. Let's take another quick simple one of 3x plus 8x equals 88. All right, so what's step 1? Simplify. Simplify on each side of the equal sign. So when I look here, here's the equal. On the right side, there's an 88. I can't simplify 88. 88 is 88. When I simplify right here, 3x plus 8x, what is that? Of course, 11x. Good. 11x equals 88. All right, now I'm looking at step 2, transpose. Well, I could transpose the 11x over here or the 88 over there, but it wouldn't really help me. The like terms really are already separated out on either side of the equal. This is the only term over here. The only one over here is the 88. No reason to transpose anything. It's not going to help me to do anything. So my big issue, remember the goal is to isolate x. My big issue in isolating x is that 11. That 11 is a coefficient, so I'm going to use the multiplication principle to divide it off. So I'll divide this side by 11 and divide this side by 11. Cancel out, get x equals 8. Okay, so there's another quick example of solving. All right, another quick example of solving. All right, let's move to another. Give you another example. We're going to do one that's a little more complicated looking here. Let's do 10 minus 5, and then in parentheses, let's go 5 minus 2x, 5 minus 2x, and then let's say that equals 5 times x minus 1. So 10 minus 5, parentheses, 5 minus 2x equals 5 times x minus 1. Fairly long, complex looking equation. But I tell you, when we go through these steps and we just follow the steps and we know how to do each one, this becomes very simple and gets a little smaller and easier all the way down. All right? So what we'll do is simplify on each side of the equal. Okay, so here's my equal. When I simplify over on this side right here, remember I'm going to do my distributive stuff, my distributive property, before I try to combine any like terms. So I'll distribute the negative 5 through the parenthesis. So a negative 5, not just a 5, but a negative 5 times a 5 is a negative 25. And then again, a negative 5 times a negative 2x is going to be a positive 10x. Now bring down this 10. Okay, so I distributed the negative 5 through the parenthesis. Negative 5 times 5 is negative 25. Negative 5 times negative 2x is positive 10. I can simplify this side a little bit more. The 10 and the negative 25, when I go ahead and put those together, I'll get a negative 15 plus 10x. So the left side of my equation is now simplified as much as possible. Let's simplify the right side. It's a little easier to simplify. It's pretty straightforward there. It's really just distribute the 5 through the parenthesis. What do you get when you do that? See if you can write it down before I do. Okay, so hopefully what you got, 5 times x is 5x, and 5 times negative 1 is negative 5 right here. All right, so I've done all the simplifying I can. I've handled step 1 here. Now step 2, I'm ready to start transposing. I'm ready to move stuff around. Now I would love to get the 10x and the 5x together. I'd love to get the negative 15 and the negative 5 together. So let's do this. Let's get our x's over there on the left. Let's leave the 10x over there, okay? It's a positive 10x. Let's just leave it there. Let's take the 5x across and make it a negative 5x. All right? If x's are going over there, okay, on the left side, let's take the negative 15 and pull it over here and make it a positive 15 with this negative 5 that's over here. Okay? So we did a good bit of transposing right there. Make sure you're with me. I transposed the positive 5x over to the left and made it negative. The 10x stayed positive. I transposed the negative 15 across over to the right side and it became positive, and the negative 5 stayed negative. Let's simplify that. We'll get a 5x right here. We'll get a 10 right here. So that's my transposing. Now I'm ready for step 3. I'm going to go ahead and use the multiplication principle to clear the coefficient off the variable. So divide this by 5, divide this by 5. Leaves me with simply x equal 2. X equal 2. Good? All right. Let's take a look at one more and see what we've got. And I think, except for a couple of special situations I'll come back on another video and do, I think that'll take care of us for this section. So let's take a look at 3p plus 7. 3p plus 7 equals 5. Okay, equals 5 minus, and then in parentheses, 8p plus 2. All right. I wanted to do this one because of the minus in front of the parenthesis here. Let's take a look and see what happens, and you'll see what I'm getting at here. The first thing I want to do is simplify on both sides of the equal. Well, guys, there's the equal. On the left side, I cannot simplify 3p plus 7. 3p plus 7 is going to stay 3p plus 7. They're not like terms. There's nothing to distribute. Now, on the right side, I can simplify a little bit. Let's just get this 3p plus 7 recaptured here. I can simplify because I have a parentheses. Now, I want to distribute through the parentheses. A lot of people make the mistake of thinking I'm going to distribute the 5 through the parentheses, but no, I'm not distributing the 5 through the parentheses. What I'm going to distribute through the parentheses is simply that negative sign. It's sort of like multiplying through the parentheses by negative 1. It's like there's an understood negative 1 right here. All right? So I'll leave the 5 alone. I'll distribute the negative through the parentheses, and what will happen is this negative times this positive will give me a negative 8p, and then this negative times this positive will give me a negative 2. Now, a lot of people really miss that positive right there turn into a negative, but be careful with that. Negative times positive is negative. Negative times positive is negative. All right? We can simplify a little bit more over here on the right now. We can take the 5 and the negative 2, and so what we'll get out of that is a, what is that? A negative, that's a positive 3. It's a positive 3 minus 8p. Over here, we're still dealing with 3p plus 7. So the 5 and the negative 2 is a 3, negative 8p is right there. All right? So we have now simplified both sides. Now, let's go to transposing. Let's do some quick transposing here. Let's get the p's over on the left. Let's get the numbers that don't have p's on the right. So what will happen is the 3p will stay over there on the left. Negative 8p jumps across, becomes a positive 8p. The 3 is good where it's at. The 7 comes across, jumps across, and becomes a negative 7. Okay, so we transposed a couple of things. So we've got 11p here. We've got negative 4 here. All right, and so finally our last step here, third step, is to use the multiplication principle. Divide this by 11, divide this by 11, cancel, cancel. P equals negative 4/11ths. Strange answer, but a correct answer, a good answer. All right, guys, went a little long on this, but there's a lot of problems to show you. I wanted to make sure you saw how to do the ones that are there. This is the basis of beginning algebra. Work hard on those. Maybe do some extra problems, do similar exercises, even when you get them right, just to get some extra practice in. I'm going to come back next time with some information on how to deal with some fractions and a couple of special situations as well. So I will see you on the flip side.